we have looked at previously, solvable for p and solvable for x. Now let's look at solvable for y. Okay, suppose f of x comma y comma p is equal to 0. Remember, p is dy by dx. Can be solved for y, that is in terms of x and p. So which means we will end up with y is equal to a function with respect to y comma p. Now if we differentiate this, we get dy by dx is equal to, let's say, a function phi x comma p comma dp by dx. We are differentiating with respect to x. Now dy by dx is nothing but p, so p is a function, p is equal to a function of xp and dp by dx. Now this is a first order differential equation in x and p. Now when we solve it, solving this dE, we get, let's say, f of pxc equal to 0. That is, if it is possible to solve it. Now eliminate p between y is equal to f of x comma p and f of px comma c equal to 0. Now if you can't eliminate b, if not possible, then solve for y equal to f of x comma p and f of pxc equal to 0, and you get the solution. Now let's actually see how we solve problems. Now let's look at the first one. Y is equal to x plus 2 tan inverse of p. Now it's already solved for y, so let's differentiate. Dy by dx is equal to 1 plus 1 by 1 plus p square dp by dx. Okay, now this is nothing but p, and let's take p to the other side. So we get 1 minus p plus 2 by 1 plus p square dp by dx equal to 0. Okay, now let's take the variables, separate the variables. So we get 1 minus p times 1 plus p square dx plus 2 dp equal to 0. And now take the rest except dx to the other side. So dp 2 dp minus 2 dp by 1 minus p times 1 plus p square. Now we have to split this into 2. So partial fractions. Now I already done a whole series of videos on partial fractions. It's available as a playlist. Have a look at that. So here I'll just take a shortcut and directly say that this can be written as dp, let's take the minus to the other side, by 1 minus p plus pdp by 1 plus p square plus dp by 1 plus p square. If you want to verify it, just take the LCM and add it up. Okay, now what we'll do is, and let's take this dx also to the other side, so plus dx, so here it becomes 0. Now let's integrate. Okay, so this would be dp will disappear. So now this will be log of 1 minus p. Immediately you verify by actually differentiating this. So log 1 minus p will be 1 by 1 minus p times minus 1. So put a minus here. plus. Now here again, if you take log of 1 plus p square, you get 1 by 1 plus p square times 2p. Yes, so we need to get rid of that 2, so 1 by 2 plus. Now here p is not there in the top, so we can't just directly say it log. Why? Because 2 will end up with 2 on the top. So this is actually the differential of tan inverse of p plus x equal to c. Okay, now let's bring this here because plus sign is there. So 1 by 2 can go up. So we have log of square root of 1 plus p square minus log of 1 minus p plus, and this is plus tan inverse of p plus x is equal to c. Now we want it in terms of x because we can't really simplify this any further. We can't really eliminate p. So what we'll do is we'll put it in terms of x itself. So x is equal to, and let's take all these to the other side. So log of 1 minus p minus log of square root of 1 plus p square minus tan inverse of p plus c. And y is equal to, our problem statement itself says y is equal to x plus 2 tan inverse of p. So this is the set of equations which provides the solution. Okay, let's look at the second one. Y is equal to p sin p plus cos p. Let's differentiate this. Dy by dx is equal to p sin p. So p cos p dp by dx plus sin p dp by dx minus sin p dp by dx. This and this gets cancelled. Now let's move this around. This is nothing but p. So p cos p dp by dx. This p gets cancelled. So we have cos p dp by dx is equal to 1. Now let's separate out the variables. So we have cos p dp is equal to dx. Okay, integrating we get x is equal to sin p plus c. Again, we can't really eliminate p. So this is our set of equations which provides the solution. This is our problem statement itself. Okay, let's look at the third one. 16x square plus 2p square y minus p cube x equal to 0. Remember, we have to solve it for y and then differentiate. So 2p square y is equal to p cube x minus 16x square. 2y is equal to p cube x by p square minus 16x square by p square. P square and this gets cancelled. So we are left with px minus 16x square by p square. Now this is 2y is equal to px minus 16x square by p square. Now let's differentiate this. So we get 2 dy by dx is equal to p plus x dp by dy minus, now we have to apply the quotient rule. So p square as it is 32x minus, now differentiating p square we get 2p. 2p is in times 16 is 32p and x square as it is, and dp by dx divided by p to the power of 4. Okay, now this is nothing but p is equal to p plus x dp by dy. Let's split this, so minus p square 32x by p4 plus 32px square by p4 dp by dx. Now let's take p to the other side, so minus p plus this, so we get p. Let's bring in this also to the other side, so p square, or let's write it properly, 32p square x by p4. Let's do the cancellation also, so p square and 2 of this will get cancelled, so we can bring in plus 32x by p square is equal to x minus, no, plus 32px square, again p and this, so this becomes p gets cancelled in the numerator, so x square by p cube, and common is dp by dx. Now in this let's take out p common. So if we take out p common, what are we left with? 1 plus 32x p cube, then only one of the p's will get cancelled and it will be left with p square. Let's take out x common, so we are left with 1 plus 32x by p cube dp by dx. Let's bring it to the same side, so p 1 plus 32x by p cube minus x times 1 plus 32x by p cube dp by dx equal to 0. And this is common, so p minus x dp by dx 1 plus 32x by p cube equal to 0. Okay, now this will give us only one single solution, so let's focus on this. P minus x dp by dx equal to 0. So let's separate out the variables. So for that we take it to the other side, it becomes minus p, minus minus gets cancelled. Okay, so x dp by dx is equal to p. Now let's take dx to the other side, dp by p is equal to dx by x, and we can bring this to this side itself. Now integrate, what do we get? We get log of p minus log of x equal to log of c. Now remember, we want to eliminate p, so we want this in terms of p. So log of p is equal to log of x plus log of c, log of xc. Let's exponentiate both the sides, so log gets cancelled, so p is equal to xc. Now let's put this in our equation. 16x square plus 2p square y minus p cube x is equal to 0. So 16x square plus 2p square will be x square c square minus x cube c cube times x. So which means we can make it as power of 4 is equal to 0. So this is our solution. Okay, let's look at the fourth one. xp square minus 2yp plus ax equal to 0. So minus 2yp is equal to minus xp square minus ax. Minus 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 get cancelled. Y is equal to, or 2y is equal to xp square by p plus ax by p. P and one of the p's get cancelled. So 2y is equal to xp plus ax by p. Now differentiate with respect to x. 2 dy by dx is equal to p plus x dp by dx plus quotient rule. So p square, and here p as it is times a minus ax as it is dp by dx. dy by dx is nothing but p equal to p plus x dp by dx plus pa by p square minus ax dp by dx by p square. So here p get cancelled. Bring p to this side, so this becomes 2p minus p. Let's bring in this also, so minus a by p, and here dp by dx is common, so x minus ax by p square dp by dx. Let's take out p common, so 1 minus a by p square. Let's bring in this to this side, so minus, and let's take out x common, 1 minus a by p square dp by dx. This and this is common, so p minus x dp by dx times 1 minus a by p square equal to p. Again, this does not contain dp by dx, so let's take this further. P minus x dp by dx equal to 0. So x dp by dx is equal to p. Okay, now let's separate out the variables. So we get dx by x is equal to dp by p. Now integrate. We get log x is equal to log p plus log c. So this becomes log x is equal to log of pc. So exponentiate both the sides, logs disappear, so x is equal to pc, or we can say p is equal to x by c. And this we can eliminate it from the original. So xp square minus 2yp plus ax equal to 0. So x by c square minus 2y x by c plus ax equal to 0. Now this becomes x cube by c square minus 2xy by c plus ax equal to 0. Let's take the LCM. X cube minus 2xcy plus ac square x equal to 0 divided by c square. this c square when it goes to the other side becomes 0. Okay, x is common here, so x we take it out. X square minus 2cy plus ac square equal to 0. And if we take it to the x to the other side, it disappears. So our solution is x square minus 2cy plus ac square equal to 0. And we can write it in terms of y. Right? So that is just a different way of writing the same thing. So that is the solution. So that is solvable for y. And that's it for today. Bye for now.